Hi, everybody. Thank you very much for being here. Thanks to HashiCorp. Also, thanks to Terraform community. And finally, thanks to ADL Digital Labs, the company that I work for. The title of my talk is Automating Chaos Engineering Game Days with Terraform. Nice to meet you. I am Yury Niño. I work as DevOps engineer for ADL Digital Labs, a company in Colombia that provides technology and innovation services. Also, I am chaos engineering advocate in my country. When I was a little girl, I remember my mother telling me, don't point at people, it is rude. In many cultures, finger pointing is considered as an inappropriate behavior, and it is a gesture of blaming. However, we are still finger point others when something goes wrong. It is common to listen to these questions. Who is the blame when something goes wrong? According to the psychologists, finger pointing is a signal of self-preservation. It is something that makes us humans, but it causes a lot of problems because it is common in an organization with this culture. Nobody feels safe, there is no trust, and probably chaos is near. But the question in this part is how to avoid a blame culture in your teams. It is the topic of my talk. In the next minutes, I am going to explain what is chaos engineering, what are the chaos principles in order to promote the chaos engineering in an organization. I am going to explain what are chaos game days and how run a game day in your company. And I am going to explain why it is hard, it is difficult. And finally, I am going to show how you can to automate these activities using Terraform, and specifically Terraform modules. So let me start by defining what is chaos engineering. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system capability to withstand turbulent conditions in production. Please keep in your mind these two words, experimenting and in production. This definition was taken from chaos principle of chaos website. The discipline is practiced following these four principles. In the first step, or the first principle, is hypothesize about a steady state. A steady state is an state in which your application runs normally. So it is difficult to identify when your application is in this state, but try to use metrics or different measures in order to identify if you are ready to practice chaos engineering. In a second principle, vary real events. For example, change the values in a configuration file. In this case, the idea is to modify things that can have impact in your application. And in the third principle, run the experiments verifying hypotheses when, for example, the server crash or network connections are, have a failure. And finally, automate the experiments. That is the focus of our presentation. So in order to adopt a chaos engineering culture in your company, in the first book published by Netflix about chaos engineering, we have a chaos maturity model. Chaos maturity model gives us a way to map out the state of a chaos program in our organizations. It has two metrics, sophistication and adoption, in order to identify your progress about chaos engineering in the organization. These two metrics are very important because without sophistication, the experiments are dangerous, unreliable, and potentially invalid. And without adoption, the tooling will have no impact. So the idea is to follow this model in order to promote chaos engineering in an organization. The question here is how to achieve sophistication and adoption in an organization using this chaos maturity model. So Netflix proposed these characteristics in order to identify if your company is sophisticated and is in adoption about chaos engineering. So organization is sophisticated when setup, analysis, and termination are automated. For example, if your experiments run in production, you are in a high level related with sophistication. Another characteristics include setups and analysis are automated. You are able to run a continuous experimentation. Experimentation business metrics are part of your KPIs. And finally, the results are tracked over time and tooling, and you have tooling to support the chaos practice. In another side, the organization is in adoption when the experimental verifications are performed in game days. And please keep in your mind this word, chaos game days. So some characteristics that that allow us to identify is if an organization is in adoption is when, for example, your team is dedicated to chaos engineering, when you have to chaos engineers in your organizations, and these roles are part of a engineering team, you are in an adoption level. So another characteristics includes regression experiments and the most service practice chaos experimentation, and the most important, you practice chaos game days. That is the focus of our talk. So the idea in the next part is to explain what is chaos game days, and how you can run chaos game days in your organization. The chaos game days are inspired in the classical game days created by Jesse Robbins when he worked for AWS. Game days are an interactive team-based learning exercise designed to give players a chance to put their skills in a technology to test. Please keep in your mind this word, technology. Because, in the other hand, Chaos Game Day is an event host to conduct chaos experiments against components of your system to validate or invalidate hypotheses about a system resilience. And the focus is different because when you are talking about game days, you are talking about technologies. And in this case, we want to validate hypotheses about the resilience. So the Chaos Game Days provide teams with the opportunity to execute potentially highly disruptive experiments in a safer and more controlled way. When you practice Chaos Game Days, teams can then exercise their recovery procedures and validate their resolution protocols. So there are different ways to run a Chaos Game Day, but I am going to explain and a common methodology to run Chaos Game Days. So in a Chaos Game Days, a master of, we have three roles in this case. We have three roles, one for master of disaster, first on-call person, and team. In a Chaos Game Day, a master of disaster decides, often in secret, what sort of failure the system should undergo. So basically, this person decides the failure and declares a start of the incident and attack. And with the team gathered in one room, for example, or this event can be run in a physical or virtual location. So with the team in this place, the master of disaster declares a start of the incident and then cause the plane failure. So one member of the team acts a first on-call person and in a first step, try to identify, try to see, triage, and tries to mitigate whatever failure the master of disaster has caused. And finally, if the first on-call person can't mitigate the incident, the team, the responsibility of the team is attend to the failure. And for this, they have to dedicate the 75% of the allocated time to solve the issue. And finally, they have the responsibility to write up a postmortem. So how to plan a chaos game day? It is a list of steps proposed by Russ Miles in the second book written for chaos engineering. The title of this book is Learning Chaos Engineering. And in his book, he proposed these 10 steps to plan a game day, plan a manual game day. So in the first step, the idea is to choose a hypothesis in order to verify something related with our application or with our hardware. In a second step, the idea is to pick a style of the game day. If you remember, I mentioned that there are many ways to run a game day. So in the next part, the idea is to decide who participates in the event, who observes, choose a location, choose the date, and that is a planning activity. They are planning activities. And after that, the idea is to describe the game day experiment. And in the next, you have to get approval, because probably you need to talk with product owners or managers, because you need the time of the engineering team. So the idea is to get approval for this. And finally, run the game day. And it is important to consider an observability tool in order to have a strategy to identify the issue and follow logs, for example. As you notice, it is a lot of work, and if you consider you have to run this in a manual way, that is difficult. So probably when you decide to start with a chaos game day, you think it is an easy activity. But the truth is that planning a game day requires giving a large amount of lead time, because you need to manage people, times, locations. For example, if you want to run the activity with food, music, you have to provision all this for the activity. Now think if you run this in a manual way, as I mentioned. For example, you have to define an hypothesis. For example, you need to write this in a document, and you have to define who, and you have to keep a list of contacts, for example, and you have to define when and where. You have to manage a calendar and a list of events and the time of the people involved in the event. And finally, and the most important part, you need to prepare the infra for the chaos, and you need to provision, for example, AWS infrastructure in order to have a place to run your experiments. And you have to install in this infrastructure a chaos attacker. For example, you have to install a Gremlin agent or a Chaos Mesh agent in order to have the possibility to attack the infrastructure and the applications. And according to the recommendation of Russ Miles, you should install Datadog or New Relic agent in order to have a tool to observe your application while the attack is happening. And finally, you need to alert the people involved in the event. So probably you need to create a channel in Slack or provide a strategy using PagerDuty, for example, in order to alert the people. And these tools and this provision have to interact with your system. Sorry. sorry, yeah. For this case, Terraform can be very useful because in the last slide, I showed us run a Chaos Game Day, or plan and run Chaos Game Day using a manual way, but it is a lot of work. So for this case, Terraform can be very useful. With Terraform, we are able to provision the infrastructure required in each step using code. So what is Terraform? Terraform, as you know, Terraform is a technology created for HashiCorp to practice infrastructure as a code. With Terraform, we have the possibility to build, change, and version control our infrastructure. People think that Terraform is just provisioning infrastructure in any cloud provider, but Terraform is more powerful than that. Terraform can do API calls to any technology that allow to create a resource through an API. So the question here is how to automate Chaos Game Days with Terraform. And for this use case for Terraform, we need an AWS account, a Terraform installed in our local machine, and a connection to internet in order to have access to the dependencies of providers or anywhere you need to the experiment. And finally, we need a Gremlin account. So in the next slides, I am going to explain how you can run how you can provision an infrastructure prepared for chaos engineering, useful for a chaos game day using Terraform. So they are the ingredients for this recipe: an AWS account, a Terraform installed in your local machine, a connection to internet, and a Gremlin account. Here, the Terraform, here in this slide, we have a Terraform main file with the definition to provision an EC2 instance in AWS. So in this case, a Terraform configuration file consists of blocks and expressions that allow us to provision an EC2 instance in AWS. The idea is to use a user data field in order to provide the commands required to install a Gremlin attacker, for example. So for more details related with this installation, related with the Gremlin installation, please refer to the Gremlin documentation. However, in this slide, however, in this slide, or for this particular case, we have the commands required to install Gremlin in a machine. So in this case, I am using to install Gremlin when the EC2 is launched. So with this definition, the idea is to run the init Terraform command and apply the configuration. So you write these commands in a main Terraform file and run these commands in order to provision the infrastructure. So it should happen if the configuration file is okay. It should be happen after you run the commands. After you run the apply, the configuration, you should have an EC2 instance in AWS, like this. And the great thing is that this instance has an attacker installed in it. So if you access, for example, using an AWS CLI, you should see the Gremlin installed. And if you and another easy way to confirm the installation is using Gremlin console. If you access to Gremlin, because in the other side, we install an EC2 instance with Gremlin installed in it. But in this case, we are entering or accessing to Gremlin console in order to verify the installation. If it was okay, so we should see the instance running in there. So log in with your credentials in a Gremlin account, in a Gremlin site, and verify the instance you just created is ready to be attacked. Gremlin offer different ways to, or different attacks in order to build different experiments to attack the infrastructure or the applications. So previously, we have managed only one resource with Terraform, a single EC2 instance, and we install a chaos attacker. But the real infrastructure is much more complicated than a single server. So, and probably you need to run this many times because you need to plan many game days. So each time to need to provision infrastructure for a game day, you have to run this. So for this, Terraform provides a great way to deal with this challenge. They are the Terraform modules. Terraform modules are reusable Terraform configurations that can be called and configured by other configurations. Most modules manage a few closely related resources from a single provider. Modules can be used to abstract the logic associated to the use case for Terraform. That is a best practice, for software engineering, because the idea is to abstract the logic required to and not repeat the steps in when you are, for example, that is our case, provisioning infrastructure. With modules and provisioning that were achieved, this file structure, and now we can run with less files, because in the first part we have a configuration without modules, and when you use modules, variables, and outputs, you have the possibility to condense in a file or in a few files this information and reuse in another use cases. So following the principle, don't repeat yourself, that is a famous principle in software engineering, and the instructions to build modules, you can use the same logic for different scenarios, or for our case, for different game days. Here we have the same main Terraform file, but now we are using variables. If you notice, we have the values of the, for example, the instance type or the regions are variables and not the specific value. So something interesting in that in this configuration is that we can separate the commands to install the chaos provider in a different file. So for example, we provided a chaos attacker with Gremlin, but probably for example, you want to use another chaos attacker, you have the possibility to do this using using a separated file. So in this case, I am using the user data in the last case, but the value is a name of file. So in this case, we have the possibility to change the commands to install the chaos attacker in this file. For example, you have the possibility to install a chaos toolkit or chaos mesh in order to have infrastructure prepared for chaos engineering, but with different attackers. And in this case, we have the variables, the Terraform variables file with the definition of the variables. For example, we are using variables for AWS region, AMI ID, instance type, and so that is an example of you can automate chaos game days using Terraform, because using Terraform, you have the possibility to run game days in many times using the same logic condensed in a module. So probably this can reduce the times and improve the planning in order to in order to automate this work that I mentioned, that is a lot of work. So the example is related with the infrastructure, because we provisioned an EC2 with a chaos attack. But as I mentioned, you need to plan the activities with a Google Calendar, and probably you need a Slack channel and a PagerDuty system alerting anywhere. So Terraform provides a Terraform Jade registry with an easy way to use any provider or module for this. And probably if you don't have a module for your specific tool or your specific activity, Terraform provides a way to write our providers or our modules, as I mentioned, as I showed. So, but before this, the idea is to access to Terraform registry in order to verify if there is a provider or a module for our requirement. So the Terraform registry make the Terraform registry offers the providers and modules, as I mentioned, but another strategy to automate Chaos Game Days is with providers. I mentioned modules, and I explained and I show us an example with modules, but you can use providers in order to change, for example, the cloud provider, because in this case, we are using the AWS provider to provision an EC2 instance, but you can provision infrastructure in GCP or Azure or anywhere cloud provider using the different providers available in the Terraform registry. And my final invitation is to run Chaos Game Days, because they are a great way to promote teamwork and build more resilient software. If you remember, as I mentioned, the idea with chaos engineering is, attack your application, but the chaos engineering has another purpose is that to build resilience applications. So the game days, they are a great way to promote this practice in your organizations. And I would like to share this final sentence. Everything fails all the time is a sentence from Werner Bowles, and your software is susceptible to failure all time. So chaos engineering can help in order to build resilience applications. So thank you very much. Thank you very much for being here. And if you have questions or you have any great idea to automate chaos engineering steps with Terraform, please don't hesitate to write me. They are my contact data in LinkedIn, Medium, and Twitter. I am Yury Nino in there. Thank you very much.